Imagine standing in the darkest corner of the universe, far away from stars, planets, or any form of life. Out there, the background temperature of space itself settles at about 2.7 Kelvin, just a couple degrees above absolute zero, which is the lowest temperature possible in physics. That's unimaginably cold compared to anything on Earth. But surprisingly, it's not the coldest place we know. Scientists have discovered something even colder than the natural chill of space, and the story of how it was found will make you realize how mysterious and fascinating our universe really is. To understand this strange discovery, we first need to take a step back and think about what it actually means for something to be cold. Temperature is simply a way to measure how much energy particles have. The hotter something is, the faster its atoms and molecules vibrate. The colder it is, the slower they move. Absolute zero, which is defined as 0 Kelvin, or about minus 459 degrees Fahrenheit, is the point at which atoms would theoretically stop moving altogether. We've never quite reached that limit, but scientists on Earth have gotten extremely close in laboratories, creating ultra-cold environments where atoms move so slowly they begin to display weird quantum effects that we don't normally see. But out in the universe, without human interference, the baseline coldness of space comes from the cosmic microwave background radiation, the faint afterglow left over from the Big Bang. That background keeps the universe from ever truly reaching absolute zero. Now, here's the twist. Somewhere in space, there's a place that is even colder than the vast emptiness of the cosmos itself. This place is called the Boomerang Nebula, a cloud of gas and dust located about 5,000 light-years away in the constellation Centaurus. At first glance, it looks like any other nebula, but when astronomers measured its temperature, they were shocked to discover it was just 1 degree Kelvin above absolute zero. That's colder than the average background of space. In other words, this nebula is literally the coldest known natural place in the entire universe. But how is that possible? How can something out there, floating in space, actually be colder than space itself? To answer that, let's think about how the Boomerang Nebula was formed. At the center of this nebula is a dying star, one that's in the final stages of its life. As it runs out of fuel, it sheds its outer layers, ejecting gas and dust into the surrounding space. Normally, when stars do this, they create what's called a planetary nebula, a beautiful, glowing shell of material illuminated by the core that remains. But in the case of the Boomerang Nebula, the star's outer material is escaping at an extremely fast rate, about 100,000 kilometers per hour. This rapid expansion causes the gas to cool dramatically, just like how air from a can of compressed gas feels cold when it's released quickly. It's the cosmic version of that effect, only on a much larger and more powerful scale. So here we are, looking at a patch of the universe where the temperature is actually lower than the surrounding space itself. When scientists first studied the Boomerang Nebula using radio telescopes, they could hardly believe their data. The numbers suggested that the temperature was about 1 Kelvin, making it colder than the background radiation. And that discovery raised deeper questions. If nature can create a place this cold all on its own, what other extreme conditions might exist out there that we haven't even noticed yet? Think about it for a moment. The universe is already a place of unimaginable extremes. The hottest stars blaze at millions of degrees. Black holes twist space and time into shapes that defy logic. And yet, at the other end of the spectrum, we find a frozen cloud of gas that outpaces the coldness of intergalactic space. For astronomers, the Boomerang Nebula is like a natural laboratory, a place where the boundaries of physics are pushed to their limits. It challenges our assumptions and gives us a chance to test what we know about matter, energy, and the life cycle of stars. When you consider just how fragile life is compared to such extremes, it puts things into perspective. Earth orbits within a narrow zone around the Sun, where conditions are just right for water to remain liquid and for temperatures to be relatively stable. But take one step into the cosmos beyond our atmosphere, and you're suddenly dealing with temperatures that no human body could survive for even a fraction of a second. The Boomerang Nebula reminds us that while space might seem uniformly empty and cold, it's actually filled with hidden surprises that defy expectations. And yet the coldness of this nebula isn't permanent. Over time, as the dying star at its center continues to evolve, the gases will warm up and eventually glow brightly, like other planetary nebulae. What we're witnessing now is just a brief, rare stage in the life of a star, a moment when conditions create the coldest known environment in the cosmos. That fleeting state makes it all the more fascinating, because it's like catching a glimpse of a star in transition, showing us something that's almost never seen anywhere else. So when we ask the question, what's the coldest place in the universe? The answer isn't simply outer space. It's actually this fragile, expanding bubble of gas around a dying star, sitting thousands of light years away, quietly breaking records by being colder than the universe around it. And if that isn't strange enough, the more we study it, the more it teaches us about how stars live, die, and shape the galaxies around them. When we think about the vastness of space, it's easy to picture it as a quiet, empty darkness where nothing much happens. But the truth is, space is full of violent, dramatic processes. Stars explode, galaxies collide, and black holes swallow light itself. Against all that chaos, the idea of a place so still, so cold, that it dips below the natural background of the universe almost feels unreal. And yet, that's exactly what we see in the Boomerang Nebula. But to really appreciate how unusual this discovery is, we need to dig deeper into why coldness matters so much in the universe, and how scientists even managed to measure something happening thousands of light years away. Let's start with why this concept of colder than space is so bizarre. Space, on its own, is not completely empty. It's filled with faint radiation, the afterglow of the Big Bang, known as the cosmic microwave background. This radiation is everywhere, a kind of invisible blanket that sets the minimum temperature of the universe. That blanket keeps everything from cooling below 2.7 Kelvin, so when astronomers looked at the Boomerang Nebula and saw it was at just 1 Kelvin, it was like finding an ice cube in an oven that somehow stayed colder than the freezer. It doesn't make sense at first glance, and that's why it became such an exciting subject for research. But how do scientists actually measure the temperature of a nebula? After all, no one is sending a thermometer into a cloud of gas 5,000 light years away. Instead, astronomers rely on radio telescopes. These instruments detect the faint radio waves emitted by molecules in space. By studying the patterns of these waves, scientists can figure out how much energy those molecules have, which in turn reveals their temperature. In the case of the Boomerang Nebula, it was molecules of carbon monoxide that gave away the secret. The radiation they emitted matched what you'd expect from an object colder than the cosmic background. That was the first major clue that something strange was going on. And once you think about it, the physics behind the phenomenon isn't so alien. You've probably experienced a similar effect right here on Earth. Have you ever used a can of compressed air to clean a keyboard? When you spray it, the metal can gets extremely cold. So cold you can almost burn your skin if you touch it for too long. That happens because the gas inside expands rapidly when released, causing it to lose heat. The same principle is happening in the Boomerang Nebula, but on a massive cosmic scale. The star at its center is shedding material so quickly that the gas expands faster than heat from surrounding radiation can warm it. As a result, the temperature plummets below the cosmic baseline. But this discovery also highlights something deeper about astronomy, how the extremes of temperature shape the universe. High temperatures drive nuclear reactions in stars, powering them for billions of years. Extremely cold temperatures, on the other hand, slow particles down, letting scientists study strange states of matter. For example, in laboratories on Earth, physicists use lasers and magnetic traps to cool atoms close to absolute zero, creating something called a Bose-Einstein condensate, Bose-Einstein condensate, where atoms behave like a single giant quantum particle. These experiments have led to Nobel Prizes because they reveal entirely new physics. So imagine what might be possible when nature itself creates ultra-cold environments in space. What kinds of unique physics might be happening inside the Boomerang Nebula, beyond what we can detect from Earth? It's also worth considering how fragile this cold state really is. The Boomerang Nebula is not going to remain the coldest place forever. As the star at its center continues to evolve, it will eventually heat the gas, and the nebula will start to glow like others we've seen across the sky. Right now, astronomers are witnessing a very brief, rare stage of stellar life. In a cosmic sense, it's like catching a single frame of a movie that usually passes too quickly to notice. That's part of what makes the discovery so valuable. It's not just about coldness, it's about catching a dying star in a unique act of transformation. For astronomers, studying these extreme conditions isn't just about satisfying curiosity, it's about answering fundamental questions. How do stars die? How do they recycle their material into new stars and planets? How do the most basic rules of physics operate when pushed to their limits? The Boomerang Nebula is like a natural experiment that lets scientists test their theories. For instance, the rapid expansion of gas there shows us how stars lose mass. which eventually contributes to the formation of new star systems. Without processes like this, the universe wouldn't have the elements needed for life. In a strange way, even though this nebula is incredibly cold and seemingly lifeless, it's part of the cycle that makes life on planets like Earth possible. Now, let's bring this back to something more relatable. When we talk about the coldest places on Earth, you might think of Antarctica, where temperatures can drop below -100 degrees Fahrenheit. That's so cold that even breathing can hurt your lungs. But in comparison to the Boomerang Nebula, that's practically tropical. The difference is so extreme it's almost hard to grasp. If you could magically stand inside the nebula, the heat from your own body would make you blaze like a star compared to your surroundings. Your atoms would move billions of times faster than the surrounding gas. It's one of those humbling moments where you realize how delicate human life is against the backdrop of the cosmos. And yet, despite all this, our technology allows us to peer across thousands of light years and measure something as delicate as temperature. That's the beauty of astronomy. It takes the unimaginable and makes it just a little more understandable. The discovery of the Boomerang Nebula as the coldest known place in the universe is a reminder that even in a universe full of fire and chaos, sometimes the most remarkable stories are written in the quiet, frozen corners. If you've ever looked up at the night sky and felt small, you're not alone. The universe has a way of humbling us with its sheer scale and its extremes. But while most people imagine the universe as a fiery place of exploding stars and blazing galaxies, the truth is that cold plays just as important a role in shaping everything around us. And nowhere is that more obvious than in the Boomerang Nebula, the coldest known natural place in the cosmos. But to really understand why this matters, let's take a step back and look at the bigger picture of how temperature defines the universe itself. At the most basic level, temperature is about motion. When atoms and molecules move quickly, we call that hot. When they move slowly, we call that cold. That simple idea scales all the way up to stars and galaxies. The sun, for instance, is powered by nuclear fusion, a process that only works because the core of the sun reaches about 27 million degrees Fahrenheit. Without that intense heat, hydrogen atoms would never have enough energy to fuse into helium, and the sun wouldn't shine. On the opposite end of the spectrum, when things cool down close to absolute zero, the usual rules of physics start to blur. Atoms begin to lose their individuality and act as one. This is why scientists are so fascinated with extreme cold. It gives us a glimpse into a hidden side of reality. Now imagine that happening not in a laboratory, but in a nebula, drifting thousands of light years away. The Boomerang Nebula isn't just an oddity. It's a natural demonstration of how powerful temperature can be. When astronomers realized it was colder than the background radiation of space itself, it was a shock, but it also confirmed just how violent and fast the star at its center is shedding its material. This isn't a calm star fading quietly into the night. It's one that's ripping itself apart at high speed, creating an environment so extreme that it dips below the universal baseline. But here's what makes it even more interesting. The Boomerang Nebula is not unique just because it's cold. It's unique because it shows us a very narrow window into a star's life cycle that we almost never get to see. Stars are born, they live for millions or billions of years, and then they die. Most of the time, that death involves swelling into a red giant and eventually leaving behind a white dwarf, surrounded by a glowing planetary nebula. But this particular stage, when a star is ejecting its atmosphere so quickly that it supercools itself, is fleeting. In cosmic terms, it lasts only a heartbeat. Maybe a few thousand years. That's nothing compared to the billions of years a star spends on the main sequence, which means the odds of catching one in the act are slim. And yet, here we are, looking at a snapshot of this rare moment, frozen, literally, in time. That's one of the reasons astronomy can feel so magical. Every time scientists point their telescopes at the sky, they're not just looking at stars and galaxies, they're looking at moments that may never repeat in the same way again. The Boomerang Nebula is one of those moments. It's like seeing a butterfly emerge from its cocoon, but only for a split second before it flies away. If astronomers hadn't been studying it at just the right time, we might never have known this cold stage even existed. And while it's fascinating to talk about the science, there's also a sense of poetry in the idea that the coldest place in the universe comes from something that was once blazing with heat. The star at the heart of the nebula spent millions of years burning bright, fusing atoms in its core, giving off light and energy. And now, in its death throes, it has created an environment that's colder than the universe itself. It's almost like the ultimate contrast, the memory of heat giving birth to the deepest cold. Of course, the Boomerang Nebula won't stay this way forever. As time goes on, the material will thin out and the remaining star will eventually heat its surroundings, turning the nebula into something more familiar. In a few thousand years, if anyone is still watching, it will glow like other planetary nebulae, colorful and bright, which makes the present moment even more special. Right now, in our lifetime, the Boomerang Nebula holds the record for coldness. But someday, that record will be gone, and it will just be another beautiful nebula among countless others. That transience is part of the beauty. Now let's connect this back to the bigger question. Why do we care? Why does it matter that somewhere out there, in the depths of space, a cloud of gas is 1 Kelvin instead of 3? The answer is that discoveries like this remind us of how much we don't know. Every time scientists stumble upon something unexpected, it forces them to revisit their assumptions, to refine their models of how stars and galaxies work. If a nebula can be colder than the background radiation, so what else might be possible? Could there be other objects, other processes that we haven't even imagined yet? Astronomy is full of these surprises, and each one expands our sense of what's possible in the universe. It also changes the way we see ourselves. For most of human history, people looked up at the night sky and thought of it as unchanging. The stars seemed fixed, eternal. Now we know that's not true at all. Stars are born, they live, and they die. Galaxies collide and reshape themselves. And even something as quiet as a patch of gas can create conditions more extreme than anything we've ever experienced. In that sense, the Boomerang Nebula is more than just a curiosity. It's a reminder that the universe is alive with constant change, much of it invisible to the naked eye. Finally, there's the human side of all this. We're creatures of warmth. Our survival depends on a narrow band of temperatures. Our bodies operate best around 98 degrees Fahrenheit. Our cities shut down if it gets too cold or too hot. And yet, in a universe where the extremes are far beyond anything we can tolerate, we've developed the tools to not only survive, but to explore. Telescopes, satellites, and detectors allow us to reach across thousands of light years and uncover secrets hidden in the coldest corners of space. That's something worth pausing to appreciate, because ultimately, the story of the coldest place in the universe isn't just about physics or astronomy. It's about curiosity. It's about the human drive to ask questions that seem impossible and then find ways to answer them. The Boomerang Nebula is a cosmic mystery, but it's also a symbol of what happens when we keep looking, keep measuring, and keep wondering. It shows that no matter how vast the universe is, no corner is beyond our reach if we have the patience and creativity to explore it. If you've been following this journey so far, you might be wondering, what does it really mean that the Boomerang Nebula is the coldest known place in the universe? Is it just a trivia fact, like the kind of thing you'd pull out at a dinner party to impress someone? Or is there something deeper here, something that changes the way we understand the cosmos? The truth is, it's both. On one hand, it's a fun fact that captures the imagination. On the other, it's a window into the hidden rules of how stars live and die, and how the universe constantly surprises us when we think we've got it all figured out. Think about this. For most of human history, cold was something people struggled against. Before modern heating, winters could be deadly. Entire civilizations were shaped by their ability to survive harsh, freezing climates. We invented fire, clothing, houses, and eventually technology to keep ourselves warm. But when scientists talk about 1 Kelvin, that's not just cold. It's unimaginably colder than anything you've ever felt. Even the most brutal winters on Earth don't come close. Antarctica, the coldest place on our planet, bottoms out around minus 130 degrees Fahrenheit. But 1 Kelvin is about minus 458 degrees Fahrenheit. That's the kind of cold where molecules barely move at all, where normal chemistry just stops functioning. So when astronomers found such temperatures in the Boomerang Nebula, it wasn't just a neat discovery. It was like stepping into a new frontier of physics, one that only nature could create on such a grand scale. And here's where things get fascinating. The nebula's coldness actually helps preserve the material it's made of. The gas expanding out from the dying star is so frigid that it doesn't glow like normal nebulae do. Instead, it stays invisible, detectable only in certain wavelengths of light, like radio. That means when scientists look at it, they're not just seeing the aftermath of a star's death. They're looking at raw material that will one day be recycled into the universe. Stars like the one inside the Boomerang Nebula are factories. They forge heavy elements in their cores: carbon, oxygen, nitrogen, and when they die, they spread those elements out into space. Eventually, those atoms might become part of new stars, new planets, maybe even living creatures. In a way, the coldest place in the universe is also one of the quietest contributors to the cycle of creation. Now, let's put ourselves into the shoes of the astronomers who discovered this. Imagine pointing your telescope into a patch of sky, expecting to find something ordinary, and instead realizing you've stumbled across a record breaker. When the first measurements came back, showing a temperature below the cosmic microwave background, the initial reaction was disbelief. Scientists are naturally skeptical, so the first thought is always, could this be an error? But after repeated observations, using different instruments, the data held up. That's when the realization hit. They had found something colder than space itself. Moments like that are what drive the field of astronomy. It's not about confirming what you already know. It's about finding the things you didn't even think were possible. But discoveries like this also open the door to speculation. If the Boomerang Nebula can dip below the temperature of space, are there other regions out there that do the same? Could we find entire systems that are hidden because they're so cold they barely give off any light? In fact, some astronomers have wondered if there might be other ultra-cold objects waiting to be discovered, places where gas or dust expands in unusual ways. The universe is so vast that it seems unlikely the Boomerang Nebula is the only one of its kind. We may just have to wait for better instruments, more powerful telescopes, more sensitive detectors to uncover them. And here's something else to consider. Studying places like the Boomerang Nebula doesn't just tell us about stars. It also feeds into other areas of science, like the search for extraterrestrial life. That might sound strange at first. What does a freezing nebula have to do with aliens? But the connection is this. The more we understand how stars die and recycle their material, the better we understand how the building blocks of life are spread across the galaxy. Every molecule of carbon in your body was forged in a star that lived and died billions of years ago. Without nebulae like this, without the process of stars shedding their layers into space, life as we know it couldn't exist. So even the coldest, most desolate places are part of the story of life. There's also a philosophical layer here. The Boomerang Nebula challenges the way we think about limits. For a long time, scientists assumed that 2.7 Kelvin, the temperature of the cosmic microwave background, was the lowest you'd ever find naturally in the universe. It made sense. That background radiation is everywhere, so how could anything fall below it? And yet, here's a patch of space that does exactly that. It's a reminder that the universe doesn't always follow our expectations. Every time we think we've hit a boundary, reality has a way of pushing it a little further. This is part of why astronomy resonates with so many people. You don't have to be a scientist to appreciate the wonder of it. Just the thought that out there, thousands of light years away, exists a place colder than the rest of the universe is enough to spark imagination. It makes you realize how much mystery is still out there, waiting to be uncovered. And it also connects to something deeply human, our desire to explore. From the first time someone looked up at the stars and wondered what they were, to the moment telescopes detected the chill of the Boomerang Nebula, the story is the same. We are creatures who ask questions, and we don't stop until we find answers. And maybe that's the biggest lesson of all. The coldest place in the universe isn't just about numbers on a thermometer. It's about curiosity. It's about pushing the boundaries of knowledge and discovering that the universe is even stranger, colder, hotter, and more surprising than we ever imagined. It's about realizing that even when we think we understand the rules, there are exceptions waiting to be found. So the next time you look up at the stars, remember this. Somewhere, hidden in the constellation of Centaurus, lies a nebula so cold it defies the background of space itself. A nebula that is, for now, the champion of cosmic chill. And though it won't last forever, its story will. It's a reminder that the universe is alive with wonders, many of which we haven't even begun to see. So far, we've explored the mystery of the Boomerang Nebula, the strange cloud of gas that holds the record as the coldest known place in the universe. We've looked at how it got that way, why it matters, and what it tells us about stars, life, and the hidden rules of the cosmos. But before we wrap up this journey, let's take a step back and ask a bigger question. What does this discovery really mean for us? Here on Earth, living our short lives on a small blue planet orbiting an ordinary star. One way to think about it is this. The Boomerang Nebula is a reminder that the universe is full of extremes we can hardly imagine. On one end, you have stars that burn at millions of degrees, pouring out energy so intense it could vaporize entire planets. On the other, you have this quiet, dying star, shedding its layers so fast that the gas becomes colder than the rest of space itself. Between those extremes is us, clinging to the narrow strip of temperatures that allow water to be liquid, plants to grow, and life to thrive. That contrast is humbling. It shows us how delicate our situation is, and how rare it might be in the grand scale of things. But it's not just about feeling small. It's also about realizing that we're part of the same story. The very atoms in our bodies were forged in stars. The oxygen you breathe, the calcium in your bones, the iron in your blood, none of it could exist without stars, like the one inside the Boomerang Nebula, living out their lifespans, and eventually releasing their material back into space. In other words, even the coldest, emptiest places are connected to us. Without them, we wouldn't be here at all. That's a powerful idea, that something so alien, so far away, is still a part of our origin story. There's also another lesson here, one about curiosity. When scientists first turned their telescopes toward the Boomerang Nebula, they didn't set out expecting to break records. They were simply asking questions about how dying stars behave. And in the process, they stumbled across something no one thought was possible, a place colder than the background of space. That discovery came not from chasing headlines, but from following curiosity wherever it led. That's often how science works. Some of the biggest breakthroughs come not when we think we know the answer, but when we're surprised. And maybe that's why discoveries like this resonate beyond just the scientific community. They remind us that the universe is not finished surprising us. For every mystery we solve, a new one emerges. For every coldest place we identify, there may be another even stranger waiting to be found. The universe is vast, so vast that we've only seen a fraction of what's out there. The Boomerang Nebula is one story among billions, a single chapter in a book we're only just beginning to read. Think about the times in your life when you felt awe, standing at the edge of the ocean, looking out at endless waves, or standing on a mountain, staring at the horizon. Multiply that feeling by 1,000,000, and you start to get a sense of what it's like to gaze out at the universe. The coldest place in the cosmos isn't just a number in a textbook. It's a symbol of that awe, a reminder that the universe is bigger, stranger, and more beautiful than we can possibly comprehend. And yet, here we are, comprehending it, at least a little. That's perhaps the most incredible part. Despite being tiny creatures on a tiny planet, we've built tools that let us reach across space and time. We can measure temperatures in a nebula 5,000 light-years away. We can map the afterglow of the Big Bang. We can imagine conditions at the edge of a black hole. In a sense, our curiosity makes us bigger than our bodies. It allows us to touch the infinite, even if only with our minds.